Hello students, and welcome back to another geometry video. You know what to do. Pause the video, answer these questions in your notes, and then unpause them, and let's talk. So, this video marks the beginning of Chapter 7. Chapter 7 is all about polygons and different types of polygons. So, first question is, what is a polygon? We learned about polygons in Chapter 1 in Section 1.4, so I can put a link to that video in the description if you'd like. So hopefully you remembered to say that a polygon is an n-sided figure, needs to be more than two sides. Sides are straight, and we can either have convex or concave polygons. Hopefully you remembered something like that. If you want more information about concave and convex polygons, you can check out that video in section 1.4. How many degrees are there inside of a triangle? Hopefully, you remember that there are 180 degrees inside of a triangle. We learned that in section 5.1. And how many degrees are there inside of a square? Were you able to answer this? Did you have a guess? Could it be 180? Could it be the same number of degrees as a triangle? Does it need to be more than a triangle? What did you think? Maybe you said something like more than 180, but you don't know? That's okay, we're going to learn about that in this video. How many degrees are there inside a shape with any number of sides? So a square has 4 sides. What about a 5-sided shape? What about a 6-sided shape? What about a 300-sided shape? We're gonna find out in this video. So how could you find out? I'm curious as to what you said, but we are going to talk about it in this video. So, today, we are starting Chapter 7. We are in Section 7.1. Angles of polygons. So, today, we're gonna talk about what is the sum of the measures of the interior angles of a polygon. So, our learning target is that you know what the Polygon Interior Angles Theorem says. And you can use, that should not say find, you can use the Polygon Interior Angles Theorem to solve problems. So this is our learning target and success criteria. Let's jump right into it. First, a little review of what a polygon is. A polygon is a closed figure. That means that it can't be open like this. All of the vertices, all the corners need to connect. We can't have any open sides like this. A closed figure in a plane that is made up of 3 or more line segments. We can't have just 2, because if I connect 2 line segments together, that's just a line segment. So 3 or more line segments that intersect only at their endpoints. So for example, parallelograms and triangles. Those are some examples. These are also some examples of polygons. So we're going to be talking about these today. So some more polygon vocab. We learned about equilateral triangles in section 5.1 and section 5.4. In an equilateral polygon, all sides are congruent. So if we say equilateral polygon, that just means that every side has the same length. So it could look something like this. When we talk about an equiangular polygon, we learned about equiangular triangles. Equilateral and equiangular triangles went hand in hand. In an equiangular polygon, your equiangular polygon does not need to be equilateral. And you see right here that these 2 sides are longer than the other sides. So this is not equilateral, but it is equiangular because all of the angles are congruent. So all angles in the interior of the polygon are congruent. And notice that the equilateral polygon was not equiangular, right? This angle was much larger than this one in the corner. So a regular polygon is a convex, so there's no dents in it, it's not concave. It is a convex polygon that is both equilateral, and equiangular. So if you have both of these things together, we call it a regular polygon. And this is going to be important today because some of what we're going to talk about today is regular polygons, and then some parts of section 7.1 will not be regular polygons. So make sure that this is in your notes. Make sure that you understand the difference between each of these types of polygons. Now, this is fairly self-explanatory, but I wanted to make sure that we were on the same page about interior angles versus exterior angles. Now, we are only going to talk about interior angles in this video, but we're going to talk about exterior angles in a future video. So I wanted you to see them side by side so that you could see interior angles are the angles inside a polygon, right? Interior, inside the polygon. So interior angles are all of the angles that are inside the polygon. Whereas exterior angles, when you think exterior, you think outside. So exterior angles are outside of a polygon. And we're going to talk more about exterior angles in a future video. But for now, interior angles are angles inside the polygon. So, in order to understand the theorem that we're going to talk about today, the theorem in our learning target, we need to know about triangulating a polygon. So, in a polygon, two vertices, remember these are corners of a shape, so B is a vertex. So two vertices that are endpoints of the same side. So, for example, B and C are endpoints of the same side. Those are called consecutive vertices because we have one right after the other. So consecutive means one right after the other. A diagonal of a polygon is a segment that joins two non-consecutive vertices. So, for example, B and C are consecutive, but B and D are not consecutive. They don't share a side. So the segment that connects B and D is a diagonal. The segment that connects B and E is a diagonal. But B and A, they share this side right here. So B and A are consecutive vertices, and they don't make a diagonal, they make a side together. So, if I connect two non-consecutive vertices, I get a diagonal. Now, the special thing about diagonals in polygons is that the diagonals from one vertex divide a polygon into triangles. Now, for any shape, this is so cool, for any polygon, dividing a polygon with n sides into n-2 triangles. So any shape, doesn't matter how many sides it has, you can divide it into n-2 triangles. And when we're back in the classroom, we'll do a fun activity where you triangulate the shapes and you can see how many triangles you can make out of a shape. But remember our entry task? How many degrees were there inside of a triangle? 180. So if I can split a polygon up into n-2 triangles, if I can split it up into triangles, that shows that the sum of the measures of the interior angles, that all the interior angles of a polygon is a multiple of 180. So depending upon the number of triangles that are in a shape, I can multiply that by 180 degrees and get the total number of degrees in this shape. Because each of these triangles has 180 degrees in it. So how many degrees would the total shape, the total polygon have? Actually, let me leave that there. Okay, so this brings us to the Polygon Interior Angles Theorem. The sum of the measures of the interior angles of a convex n-gon, remember from section 1.4 that an n-gon means a polygon with n number of sides. where n is a number. Could be 5, could be 12, whatever you want. So the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. Because if I triangulate this shape, I'll see that I get 1, 2, 3, 4 triangles. N is 6, there are 6 sides, and I have 4 triangles. Now, so I have 4 triangles, and each triangle has 180 degrees in it. So if I want to know the total number of degrees inside of this shape, I can take the number of triangles times 180. And that's what this is. This is the number of triangles times the number of degrees in a triangle. How many triangles do we have? They each have 180 degrees. So if we want to know how many degrees, what is the sum of the measures of the interior angles for any polygon, we just need to take the number of sides minus 2. That's our number of triangles. Number of triangles times 180. So, alrighty. Let's move on to our first example and let's try this out. Find the sum of the measures of the interior angles of the figure. So, our interior angles theorem said, our Polygon Interior Angles Theorem said, that the sum of the measure of the interior angles is equal to n minus 2 times 180. The number of sides minus 2 times 180. So how many sides do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 sides. Now careful, I drew those tick marks on there just to count the sides. I am not saying that these are congruent. Obviously they are not congruent. To help me count the sides, I just put a line there as I went around so I knew where to stop. I'm starting my counting here. I also could have 1, 2, 3, 4, 5, 6, 7, 8. I could have written numbers on the outside. But don't be confused, those little lines I were drawing were not congruency tick marks. I just wanted to figure out how many sides do we have, and we have 8 sides. So, in order to find the sum of the measures of the interior angles, I'm going to take 8 minus 2, that's the number of triangles that my shape has, and multiply it by 180 degrees. So 8 minus 2 is 6, and I'm going to do 6 times 180 degrees, which is 1,880 degrees. And there you go. This shape, any octagon or 8-sided shape, that's what an 8-sided shape is. It's an octagon. Whoops, octagon. Goodness. Any octagon has 1,080 degrees in it. And we could see that if we triangulated this shape, if we drew all the triangles that this shape contains, we could see 1, 2, 3, 4, 5, 6. 6 triangles, 6 times 180 is 1,080. Let's check and see if we were correct. N minus 2 times 180, 8 minus 2 times 180, 6 times 180, 1,080. Awesome, we were correct. Now, let's move on to our next example for today. So we're still going to use the Polygon Interior Angles Theorem, but now we are told the sum of the measures of the interior angles of a convex polygon is 900. Classify the polygon by the number of sides. So now what they're saying is I know n minus 2 times 180 equals 900 degrees. How many sides are there? So it's asking, classify the polygon by the number of sides. Tell us how many sides this shape has. but all we know is that the interior angles of this convex polygon add up to 900. So what they're saying is this. I take my Polygon Interior Angles Theorem, and I know that that is equal to 900 degrees. And now I can solve this for n. I can figure out what n is. So, since I have n minus 2 times 180, what is the opposite of times 180? Divide by 180. Divide both sides by 180. And we get n minus 2 equals 5. And now, n minus 2 equals 5. I'm going to add 2 to both sides. And I get that n equals 7. So, this is, this convex polygon is a 7-gon. A 7-gon. Okay. Alright, let's check and make sure that we were correct. Alright, so we have n minus 2 times 180 equals 900. This is the most important part of the question, because after that, we just solve. Divide each side by 180, add 2 to each side, and we get that n equals 7. So it is a heptagon. A heptagon. That's the name for a 7-sided figure. So, we were correct. Okay, that is all I have for you today. I wanted to keep this video short and sweet. I really wanted to truly understand the Polygon Interior Angles Theorem. So, we're going to start with that. We're going to continue section 7.1 in the next video. But today was all about the Polygon Interior Angles Theorem. It was all about n minus 2 times 180 and using this property right here, this theorem about polygons. So, now is the time. Rate yourself on your understanding of the Polygon Interior Angles Theorem. Are you lost? Do you not know what's going on? Are you think you know what's happening, but you want to try the homework? And do you totally get it completely and you're ready to ace the homework and help all of your friends on your homework? Assess how you're feeling with the material, and here are some practice problems you can do to try. I know there's not very many of them. There's only 8 of them. But these first problems are exactly like example 1. Find the sum of the measures of the interior angles given how many sides there are. And the second set of problems is like example 2, where I'm giving you the measure of the sum of the interior angles, and you need to tell me how many sides there are. Okay, and we're going to end our video with a launch, just like usual. So, today's launch comes from Charles Dickens, and he says, "Reflect upon your present blessings, of which every man has many, not on your past misfortunes, of which all men have some." So, what he's saying, of which every man, so everybody, he's saying everybody has many blessings. And everybody has some misfortunes. So what he's saying is, you have many blessings. You have some misfortunes. Let's make that a little more clear. So you want to reflect upon the blessings that you have right now. Don't think about your past misfortunes. Oh my gosh, that thing that happened, you know, in my junior year of high school, my choir teacher gypped me out of performing at state for choir, and I was very upset about that. Let's not reflect upon that, though. Like, that was a bummer? Doesn't matter. Right now, I have so many blessings, so many things to be thankful for. I have a house. I have a job that I really, really like. I get to work with students that I really, really enjoy. There are so many things that I can be thankful for right now. So I don't need to think about, you know, all the things that happened in the past that I wasn't a big fan of. Because there's only some of those things. There's only some things in the past that I could complain about. I have so many blessings right now. My husband is amazing. My job is amazing. My family is amazing. I have so many things to be thankful for right now. My friends are amazing. So I want to focus on the things that are bringing me joy right now, the things that I am blessed with right now, instead of dwelling on all that stuff in the past that I can't change anymore. So if I focus on the things that I am happy about right now, that's going to be a much happier life for me than if I focus on all the negative things that didn't happen in the past. I can't change the past, but I can be here present in the moment and be very, very thankful for what I have here in this moment. So I would encourage you to do the same. See how it affects your mindset and your attitude throughout the day. So that is my launch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.